Howdy. So today we are going to show a quick demo of our progress in the PNNL use case, which is the multi-stage attack. So we will first start off by showing you how to run the case from the very beginning of collecting the physical data through the PowerWorld Dynamics Studio, and then all the way down to our defense, which will be in the form of data fusion for today's video. So to first start with running our simulation on this virtual machine, we would start the server, which sets up the connections with the other virtual machines in our network, and then we would start running the simulation. We can double check that our simulation options right here. This is a continuous simulation, which is important as we are running our demo in real time. And then we have already set up the DNP3 outstations, and we can double check on what data we have wanted to collect under case information. We have decided to only collect 8 data points, which would be helpful for our use case for today. And then we've set up all those points as analog outputs. And then we've collected like the generator 2 and 3 values, and then the bus frequencies, and then also the power flows between the branches. So then we would go back here, and then once we have set up everything in the DNP3 outstation, which is essentially this PowerWorld Dynamics Studio, we would go to our DNP3 master in the other VM, and then we would run this Python script, which essentially pushes the data from the DNP3 outstation and puts it in the SQL database that we've set up in another virtual machine. So once we do that, we can see that the data is being transferred and pushed. So the data points that we are going to be collecting are going to be the generator 2 and 3 values, and then our script runs and calculates the ACE values. So since we haven't done any changes to the loads in the system, the ACE values would remain as zeros, and then the last 2 values are our generator set points. So then we would go to where we set up our SQL database, and if we run it, we can see that the values are changing in real time. And actually, if we run it again, we can see that there would be more data points running as the data is being collected and the database is being filled up. So right now we have an additional point right here, and then once that is done, we could actually even verify all the way up to where we are running our ICCP to the balancing authority.
So running the ICCP server, it connects back to the SQL database. It gathers the data shown before and sends it to the balancing authority. So as we can see, it gets all the data that we need. The timestamp is transformed into seconds, generator 2, 3, and set points. And when we run the client side, we can see that these reports are being sent to the balancing authority. So 6 reports, 7, up to 11, and it finishes the sending of the reports to the balancing authority.
So now we will go back to where we set up our SQL database, and we'll talk more in details about the injection.
Yeah, so this is our SQL injection database, and that is we have hosted in the another VM, and the VM name is Substation A. And as we cut the data from the DNP3 master, we see all the populated value here in ID, time, generator 2, generator 3 value, ACE value, and set point value. And then the database name we have given is OT data. Now, if I go back, and then we have also developed a web page to access the database, and this is the basic web page we have developed. And to perform the SQL injection attack, we have taken the example of Postman, which is an API platform. And then where you see here the address bar, I have the IP address here, which the database is running in the local, and the port number 5003 in the database name. And here I'll try to change the value of I can basically change any value like generator 2 value, 3 value, ACE value, or the set point value. So here I have decided to change the generator value. And now if I put any value, let's say like for example 150. And now if I go back to my database and then I ran it again, I see the value is getting changed here. And the same value would be pushed to the ICCP. So if we run the ICCP again, I will see the value has been changed.
Yes, exactly. So moving on to where it's collected in the ICCP here.
let's assume the ICCP is running.
So we would need to kill the server and restart it again, and we should be able to see the attack. So if the attack number, if it hasn't changed, so since we're collecting it in real time, we would need to just run the attack again. If we do run the attack again and rerun it, we should be able to get the value. So yeah, okay. So yep. 1 second, let me. Okay.
As you can see, the value has changed to 150 on the generator too. And when you running the client, we'll send back these reports to the balancing authority, sending this fake data that was injected through the SQL database.
Yep. And then also for defense, we are collecting the Wireshark packet capture, and also we are running the snot. So I'm running the snot here, and then if I run the snot, I'll just check the version, which version we have. So it's 2.9.14. So we are using this one, or we can use the latest also. So here I'll check my IP address. It is running on which interface. And then from all of the port I see, it is running on the ENS 256. And then I'll start my snot now. So yeah, so the snot has started. So it is detecting, like, okay, there's a potential attack. And also what we have done, there is a data fusion also, we have set it up. And then if I connect, so I'm taking the Wireshark packet capture from my database where I'm performing the SQL injection, and where we have the database set up, basically from substation A. And then in this snot, the code which we have written in the, as you see in the step 1, I have my packet capture with the Wireshark which I have taken, and I'm running the pcap, and this is the value. And you see, as I was running in the local IP, which is 127.0.0.1, and also I'm the snot data which I was running, and then I had taken the .log files, snot log file, and I'm merging that here in the step 6. So I'm running my snot log here, and then yeah, you can see here in this step, and I have given the absolute path, and this is the path where I'm running the snot log, and these are the result. You see here the whatever I have collected from the database when I was running the attack, so it is detecting. So that's pretty much about it. How we perform the SQL injection in taking the Wireshark packet capture and running it in the data fusion, and also the snot.